Hello students, this is like a test paper which we are going to discuss. The topic which you can see here, okay, the topic is capacitor. So let's start from the first question. The first question says that a network of uncharged capacitors resistance is shown current through the battery immediately after key case closed and after a long time. So as you know, when we talk about that at t equal to 0, right? So at t equal to 0, that means the capacitor behaves like a connecting wire. Okay, there is a maximum current in the circuit. So what do we do here? So we just replace the capacitor with the connecting wire. Okay, means like capacitor is there, but it behaves like it is not there. So if I draw a circuit diagram, okay, at t equal to 0, so it will look like this one. Okay, so now you can see here these R2 and R3 are short circuit. Right, so and this is R1. So how the current will flow? So when the key is closed, the current will flow like this. So what is the current in the circuit? So current in the circuit is E by R1. Correct. And when we talk about that after long time interval, means t tends to infinity. T tends to infinity, what happens? That capacitor behaves like a broken wire. So when the capacitor is behaving like a broken wire, so how is the circuit diagram now? So I will draw the diagram again. This there will be no current in this branch, there will be no current in this C2. So if there is no current in C2, so there is no use of R2. So I just like simply removing it, because we know like if there is no current pass through any resistor, so there is no use of that resistor. So this kind of diagram will be seeing. So R1, R3 and this E and this, when the key is closed, so as you can see the current will flow like this. So R1 R3 will come in series. So what is the current here? E by R1 plus R3. Okay, so this is the current when t equal to 0, when the key is just closed, and this is the current when like after a long time. So you can see here this option A is correct here. Move to the next question. Second question, find out the equivalent capacitance between A and B. So here like we have several plates here, so we'll try to draw a replacement diagram here. So first of all, we need to find between A and B. So I'll assume that there's a battery between A and B, right? So A and these two battery plates are connected with C. So let's say these are at C here, and this plate is not connected with anyone. So I'll mark it with X, let's say. So now we can see here there are some naming here, A, C, B, okay, and there's like point X. Okay, now we'll draw a replacement diagram here. So again, as you can see, the top plates, okay, this is connected between C and H, these two plates. So between C and H there's one capacitor like that. Again, like now you have the capacitor between H and A. So between H and A there's one capacitor. Then we have a and C, and then last we have a C and B, and there's a battery connected between A and B. So that's how the diagram will look like if you draw it. Okay, equivalent diagram. So now you can see here these two are in series. All the capacitors has same capacitance, equal, identical. So I can assume like the capacitance will be epsilon naught A by D. So these two are in series. Okay, so these two are in series, so that means the capacitance is epsilon naught A by 2D, right? Becomes half, and then is in parallel with this one, so that means epsilon naught A by D, so which makes it 3 by 2 epsilon naught A by D, and then it is in series with one more capacitor. So this one and this epsilon naught A by D are in series. So what is the C equivalent then? So if you solve it, you will get 3 epsilon naught A by 5D. Right, so option B is correct. Let's come to the third question. Two identical parallel plate capacitors are placed in series and connected to a constant voltage V0. So identical hai, that means the voltage drop will be equal V0 by 2, V0 by 2. If one of the capacitor is completely immersed in a liquid with dielectric constant K, the potential difference between the plates of the other capacitor means the capacitor without dielectric. So what happens here? So when the capacitor, another capacitor connected with this V0 voltage source, so we need to find the what is the potential difference between potential difference on this capacitor. Okay, this capacitor has a dielectric. So how can we calculate? So what we need to do is like to find the charge flow here. Okay, so first of all the capacitance of this capacitor will change. Okay, and it becomes what will happen here? So it becomes K times C initial, and this is C only. So I'm assuming like initially both capacitors have capacitance C and C. Okay, so after like inserting this one, so one becomes C without dielectric, and one with becomes Kc, which is like where the dielectric is present. तो C equivalent क्या होगा यहाँ पे? तो what is the C equivalent now? तो C equivalent is Kc by K plus 1. Okay, they are in series, so this will be C equivalent. Now what is the charge flow? So it is Kc by K plus 1 into V0. So now they are asking like what potential difference between the plate of capacitor will change to. So will change to, that means V1. What is V1 here? So V1 is equal to Q by C, that is nothing but K by K plus 1 into V0. Right, so which option is correct? So option B is correct here. Clear it is? Okay, let's see some other questions. Question number 4. A capacitor is connected to a battery of EMF 10 volt and with switch S1 is closed and S2 is open. Okay, so there is a switch here which is closed initially. After a long time, switch S1 is opened and S2 is closed, then current in circuit. Okay, so what will happen here when the switch S1 is closed? So capacitor will charge. This will charge. So after a long time, that means the capacitor is fully charged. Excuse me. So capacitor is fully charged. That means the potential difference across capacitor is 10 volt. Right. It will have a maximum charge Q equal to CV. Now when switch S1 is closed, okay, when S1 is closed and S2 is open, S1 is open and S2 is closed. So what will happen? There is this battery is disconnected now. So the capacitor will behave like a battery. Okay, so it is like a RC circuit now where the capacitor is discharging. So when the capacitor is discharging, so we need to find the current. So we know the formula of current, I equal to I naught e to power minus t by RC. I naught is the maximum current in the circuit, so that will be V by R. V is 10 volt divided by R, 10 to power 3. E to power minus t. What is t here? 1 millisecond, 10 to minus 3 divided by RC. What is RC here? Just multiply them. So we'll get 10 to minus 3 only. So we'll cancel. So e to power minus 1. Here we'll get 10 to power 2. So it's coming as 0.01 by E ampere. So option A is correct here. Okay. Next question, question number 5. In the figure below, what is the potential difference between point A and B and point between B and C respectively in steady state? Steady state hai, that means all the capacitors are charged one, right? So here like what we can do here, so first of all like we'll just draw a displacement diagram. So for that first of all there's a steady state, so that means there is no use of resistors. Clear? So that means if it is C, so this is C, this is C, it is A, so this is A, this is A, it is A, it is C. Now if I draw a replacement diagram here, so this is B here, this is A, this is A, C, sorry. Now between this is B, this is B, right? So A and B, there is one capacitor, okay, 3 microfarad. Between B and this is between B and A, there is one more capacitor. Just 1 second. Between B and A, there is one more capacitor. Just 1 second. Just draw something right. Between B and A, so A, B and C. Let's draw like this. So between A and B, there's one capacitor of 3 microfarad. Between A and B, there's one more capacitor of 3 microfarad. Okay. Between A and C, there is one capacitor connected of 1 microfarad. Between B and C, one capacitor. Okay, there are 2 capacitors connected between this one. Clear? And now it says that there's a battery connected between A and C. So it is like that. So now when the charge will flow here, so the charge we can calculate here. Okay, so you can see here that this 3 microfarad, this 3 microfarad are in parallel. They are parallel in series. So what is C equivalent here? 3 3 6 1 1 2 6 into 2, 12 by 8, 12 by 8 plus 1. So it is 5 by 2. So the charge from the battery is 5 by 2 into V 100. So it is 250 microcoulomb. Clear? So this 250 microcoulomb is coming from the battery here. Now this one will distribute. So on the upper circuit, okay, just one second, thoda sa, like I'll draw like this. So Q1 will go here, Q2 will go here. So we are concerned about Q1 only. So Q1 is equal to, so the upper circuit, this one is in parallel with this one. So Q equal to CV, directly proportional to C. So Q1 by Q2 is equal to, the secant or upper circuit is 3 by 2. So 3 by 2 by 1. So 3 by 2. So what is Q1 then? 3 by 5 into 250. So it makes it 150 microcoulomb. 150 microcoulomb is coming. That means this one will distribute equally. Now 75 75, and there are 1 microfarad. That means the voltage drop across each capacitor is 75. So remaining is 25, and here it is 0. If I assume it like 0 100 here. So this is 25, this is 100. So what is the potential difference between B and C? 75. Between A and B, 25. So option C is correct here. Okay, let's move to the next question. Question number 6. The resultant capacitance between A and B is 1 microfarad. The value of C is, okay. Yeah. So you can see easily here. These are like B, 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 and yeah. So these two are in parallel. 2 plus 2, 4. Here these two are in series. 12, 6, 72 by 8, 4. And this 4 and 4 are in parallel. So 4 plus 4, 8. So we are getting 8 here, this side. So this 8 is in series with this one. Okay, so just follow my instruction here, okay. So 8 in series with this one, so it becomes 8 into 1 by 8 plus 1, so 8 by 9. So far like what we have done, to A, one capacitor C, and then we, then we have this 8 by 9, okay. And here we have 1 8 and this 1 4. Clear? That's what we did so far. Now 8 and 4 are in series, so 32 by 12. So this 32 by 12 is in parallel with this one. So thoda sa simplify kar, 4 is a 32, 4 3 is a 12. So 8 by 3 plus 8 by 9. So what is it here? So 8 by, okay, I'll do it here. 8 by 3 plus 8 by 9, which makes it 32 by 9. Up this 32 by 9, the overall is in series with this one, right? So that means 32 by 9 into C divided by 32 by 9 plus C is equal to 1. That has to be 1 as from the question, right? 1 microfarad. So just solve it. So it will be like 32 by 9. If you cross multiply here, so it will be 32 by 9 minus 1. So 32 by 9 minus 9, 23. So 23 by 9, C equal to 32 by 9. So which makes it C equal to 32 by 23. Yeah. So option D is coming here. So option D is the answer. 7th question. The expression for the capacitor formed by a compound dielectric residue in the place. Yeah, so this is straightforward here. These 3 capacitors are in series. So 1 by C equivalent is equal to d1 by k1 epsilon naught a plus d2 by k2 epsilon naught a plus d3 k3 epsilon naught a. So 1 by secant is equal to 1 by epsilon naught a. So d1 by k1 plus d2 by k2 plus d3 by k3. And to find the secant, just reverse them. So we'll get epsilon naught a by d1 by k1 plus d2 by k2 plus d3 by k3. So that's it here. So option A is the answer. Clear? So far so good. Let's move to the next question then. Okay, next question by 8. 3 long conducting plates ABC having charges Q minus 2Q plus Q as shown in figure. Here plate A and C are fixed. If the switch is closed, the middle plate will start moving in. So what we'll do here. So first of all, let's see the charge distribution here. Yeah, so these 3 plates are there. Here it has Q minus 2QQ. So total charge is 0. That means the charges are 0 here. Here Q minus Q minus Q plus Q, right? So that's how the charge will distribute. So we can see here there will be attractive force between these two in this direction. There will be attractive force in this direction, and this two forces will be same. But the force depends upon the charges only. Q square by 2 epsilon naught. It does not depend upon the distance between them. Okay, right? You should know this one. Like the force between the charged particles does not depend upon the distance. Okay. So that means like the net force is 0 here. So that means that this plate will not move at all. Net force is 0, right? Question number 9. As a dielectric slab from an isolated charge capacitor is slowly taken out, the heat will be dissipated in the system, and the statement 2, work done by external force plus work done by electric force equal to 0. Yeah, so this statement 2 is correct. Okay, means like when there's a capacitor plates and when there's a dielectric, so when you're taking it out, so we know the electrostatic force will be like trying to attract it. So the work done by electrostatic force will be negative, work done by external force will be positive. So overall it will be 0. So that is correct. So it is 0. And the first statement is say that it is slowly taken out. So if it is happening slowly, so we can apply the energy conservation here, right? So if there's energy conserved, that means there will be no heat produced, right? So first, okay, agar like if in the first statement if I say this thing as the dielectric from the slowly taken out, the heat will not be dissipated in the system, that we can say that statement 1 is correct, and statement 2 will justify that statement 1. But here says that the heat will be dissipated, so that means it is wrong. It is slowly taken out, right? And when we define the potential energy also, like we say that like when the particle is moving slowly under an external force, right? So when you can do that one, like when the energy is conserved, right? The energy plus potential energy like remains constant. Okay, so there will be no loss of energy in that case, right? So option D is correct. Question number 10, the variable dielectric present. So what we'll do here, we'll take an element here of dh distance, and that capacitance of this element is epsilon naught a by dh. Now if we reverse it, it becomes dh upon the capacitance k. K is the dielectric here, right? Now we put the value of k naught plus lambda h, then lambda epsilon naught a, and all will be in series. So 1 by d c1 plus 1 by c2 plus 1 by c2. So that's how we can integrate. So on the left hand side we have 1 by secant is equal to 1 by epsilon naught a, and there's integration k naught plus lambda h, and the limit will be 0 to t, right, from here to, so this is h equal to 0, this is h equal to d, right? Now just put the values and we'll get the answer, I hope. K naught plus lambda d by k naught, the secant is equal to epsilon naught a divided by it will be like denominator 1 plus lambda d by k naught, right? So we can see that option C is correct here. Correct. Let's see the next question. Question number 11. The distance between plates of a parallel plate capacitor is 5D. So this is positive here, this is negative. Okay, one sheet is conductor, one is dielectric. So we need to find the potential difference versus X. So first of all, like we know, like when we move from left to right, the potential keeps on decreasing, right? The plus positive plate is at high potential, the minus Q plate is at low potential. In conductor, we know the electric field is 0, that means the potential remains constant, first of all. So from D to 2D, the potential remains constant. So that means these two options are wrong. Now the potential keeps on decreasing here. So from the options we can see B is correct one. In the dielectric, we know the electric field is E by K. Right, so electric field decreases, and that is why the potential difference decreases. So the thing is like in the case of vacuum, the potential difference decreases, but what happens here in the case of dielectric, that decrease happens with a low rate. Okay, because of the low electric field there. Getting my point here, right? So what we can say here, so option B is correct because the decrease in this one 3D to 4D is bit less, तो less rate से decrease हो रहा है यहाँ पे. Clear? Because that less electric field is present there. So I hope you understood. Question number 12. Dielectric sheet is placed between the plates of a parallel plate capacitor. Now capacitor is charged and battery is discharged at constant velocity. So here you need to find a capacitance where the dielectric, like some part of dielectric is inside this one, some part of it is outside. So you need to find the capacitance of this capacitor here. So these two like are in like what we can say parallel combination. So epsilon naught A by A will be like A minus H into A. Okay, because there's a like kind of a square plate, this side is A, divided by D plus K epsilon naught A X by D. So when we do the capacitance, so epsilon naught A by D is A minus H plus KX, so which is A plus K minus 1 into H. So this is epsilon naught A by D, which is C equivalent at any point of time. Now CT here, so the graph is in between C and T, so we can differentiate here. So dC by dt is equal to, what is it, epsilon naught A by D, 0 plus K minus 1 dx by dt. And dx by dt is what? The velocity, which is constant. So that means the dc by dt is constant. So slope of CT graph should be constant, which is present in A and D only. Now when the dielectric is being removed, so we know that capacitance of the capacitor will decrease. Yes or no? If it is inserted, then option A will come. If it is removed, then option D will come. So in this case, it says that it is being removed, it's taken out. So capacitance will keep on decreasing with a constant rate. That's it. Okay, let's move to the next question. Question number 13. Find time constant for the given circuit. So to find the time constant, we have a trick here. So we'll first we'll short circuit the battery here and replace the capacitor with the battery. Okay, like that. So now we'll find that R equivalent across this battery. So you can see here this R and this R in series. So 2R and R series 3R. 3R is in parallel with this one, so it becomes 3R by 4. This 3R by 4 is in series with this one, so which makes it 11R by 4 into C. So option A is correct. Question number 14. In the arrangement shown in this one, so series a parallel combination hai. I hope like this question can be done. It's easy only. So in this one, like they are connected in parallel, and here they are connected in series. So when they are connected in parallel, so K1 epsilon naught a by 2 by d plus k2 epsilon naught a by 2 by d. So it is k1 plus k2 epsilon naught a by 2d. C1 है. And what about C2? So one upon C2 equal to epsilon naught a by d by 2 k1 plus k2 epsilon naught a by d by 2. So it is 1 by C2 is equal to d by 2 epsilon naught a 1 by k1 1 by 2 plus 1 by 3. So which makes it so C2 equal to 2 epsilon naught a by d, and it is like 5 by 6, so 5 by 6 here. And here k1 plus k2 is 5, so C1 is 5 epsilon naught a by 2d, and here we have 12 epsilon naught a by 5d. So we need to find C1 by C2. C1 by C2 is equal to 5 epsilon naught a by 2d into 12 epsilon naught a by 5d. So as you can see here, it is coming as 25 by 24, right? And that is the answer. Question number 15, when the switch is closed, what is the charge flow? So when it is closed, so these are in parallel. So 3 plus 1, 4, 3 plus 1, 4, 4, 4, 2. So charges sits into 2. So 12 microcoulomb. So when the charge is 12 microcoulomb here, so that charge will distribute here 1 and 3. So let's say charge is q1 here, q2 here. So charge q equal to cv. That means charge will distribute directly proportional to capacitance. So q1 by q2 is equal to 1 by 3. So q1 is 1 by 4 into 12, which means 3. So that remains 3 microcoulomb here, 9 microcoulomb here, and in this one 9 microcoulomb here, 3 microcoulomb. So you can see here 9 microcoulomb here, and now this is 3 here. So that means 6 microcoulomb is going upward. So answer is B. The 6 microcoulomb is moving upward. Okay. So direction also we can see. Question number 16, which is based on the last question here. The sequence we calculated from you calculate half C equivalent V square potential G, and then find the force minus du by dx. So the force which will find here, okay, because here also same thing is happening, the dielectric is being removed, okay, with this mass. So the force which will calculate here, that will come as epsilon naught b v square divided by k minus 1 divided by 2d. This force will come. So it's better like you remember this formula also, that b is the width of b plates, d is the distance between the plates, okay, L is the length. Now this force acting from the capacitor plates in this direction will be balanced by mg. So that is equal to mg. So we can calculate the mass is epsilon naught b v square k minus 1 by 2 dg. Correct. So which option is correct? Option B is correct here. Let's move to the next question. Okay, question number 17. 2 microfarads charge as shown in the figure. The percentage of its stored energy dissipated after switch S is turned into position 2. So first of all, when that it is connected with 1, so this capacitor of 2 microfarad will be charged. So the potential energy in this one will be half 2v square. Now when it is connected with 2, then this capacitors 2 are connected. So there will be a common potential, right? With like 2 capacitors connected, so they'll due to potential difference there will be charge flow, and the common potential will be 2 into v plus 0 divided by 10, so which comes as v by 5. So both will have a potential energy now. So u2 is equal to half 2 plus 8 v square by 25, so which is v square by 5 only. So initial v square, now v square by 5, so percentage change, so v square minus v square by 5 divided by v square into 100, so which makes it 4v square by 5 into 100, that is 80%. As will come negative, so that means there's a loss. So dissipated only they're asking, though 80% loss is there. Okay, let's next question. A capacitor of 2.5 microfarads charged through a series of this one, in what time the potential drop across the capacitor will become 3 times that of the potential drop. So the potential drop across capacitor, okay, it is charged here. That means it is connected with the battery. So charge on the capacitor at an instant CV is equal to 1 minus e to the power minus t by RC. And this charge is like CV dash, we can write. So 1 minus e to the minus t by RC. CC cancel. Up this V dash is the 3 times the potential drop across capacitor, across resistor. So let's say the current in that instant is I, so 3IR is equal to V 1 minus e to the power minus t by RC, and this V naught I'm writing here, okay, that is the maximum here. I will be equal to I naught e to the power minus t by RC, that is the formula of current and charge. So I hope you know these formulas. So V naught is equal to I naught R, is like the maximum current. So 3 e to the power minus t by RC is equal to 1 minus e to the power minus t by RC. Now we just need to solve it. 4 e to the power minus t by RC is equal to 1. E to the power minus t by RC equal to 1 by 4. If you take ln both sides, so t by RC is equal to ln 4, which is 2 into 0.693. Now t is equal to so 2 into 0.693 into RC. RC value is given. Now if you put these values, you'll get option C. Okay, so just try it out, a simple calculation. So option C is the answer. Let's see the question number 19, which is like a straightforward question. So the equivalent diagram will be like this. These two will be in parallel here, and they are connected like this, right? So the capacitance, this one is 6 epsilon naught A by D by 2, and this one here 4 epsilon naught A by 2 D by 2, 2 epsilon naught A by 2 D by 2. These two are in series, which means 6 epsilon naught A by 2 D by 2, and this is when, so they are in series now. So these two are in parallel, sorry, and then they are in series. So if I say this is C, let's say, okay, okay, without okay, C, we cannot assume C here, C dash le lete hain. So if it is C dash, so this will be equal to C dash by 2. So these two are in series, so C dash and C dash by 2 series. So what we can write is C dash by, is like C dash by 3 here. Right, now what we can do here, C dash by 3, and just 1 second, I think like we made a mistake here. No, yeah, sorry, it's not like that. First of all, let this K3 capacitor, okay, which is connected with this 2 and 4 here, so the charge will flow like this, the charge will flow like this. That means, okay, I took it as like in series, so that means this capacitor dielectric, okay, basically is connected with this 2 here, this connected with the 4 here. So we have to divide this into 2 equal parts. Yeah, then only we can get the answer. Yes, so that's how that diagram which will be formed here. Yeah, I think like we'll get the answer now. So 6 epsilon naught A by 2 by D by 2. So I'll just divided these two like this. Okay, visualize. Now we can easily say that the charge flows through this part of capacitor will be in the same. Okay, and this the charge on this one will be in the same. Earlier, like when this capacitor was there, okay, we cannot say, right, ki the charge which is passing through this one, okay, I'll tell you this, like when I was drawing like this, right, so the charge at this point and at this point are same. That's it. So with here, like this is not like this case, the charge which enters here is equal to this point. No, so we cannot say this, right? The charge will be different here. Yes or no? So charge is different here, that's why we cannot draw this kind of diagram. Okay, so charge will distribute here itself, and whatever charge passes through this part, the same charge will flow through this one, same charge will flow through this one. Okay, so that's why like we cannot draw this one. So here sits epsilon naught a by 2 by d by 2, sits epsilon naught a by 2 by d by 2, 2 epsilon naught by 2 d by 2, 4 epsilon naught a by 2 by d by 2. So if I assume like epsilon naught a by 2 by d by 2, which is nothing but epsilon naught a by d only, is c dash. So it is c, sits c dash to c dash. So they are in series. So sits to the 12 plus 8. So 3 by 2 c dash plus here 24 by 10, 2.4 c dash. So here 1.5 plus 2.5, 4. So which is like 3.9 c dash, and c dash is nothing but c only. Epsilon a by d only, 3.9 c. Yeah, so just be careful with this type of questions, right? Question number 20. They're asking like the electric field here, the surface field in the ST, then electric field at P and P dash. Okay, now we know like the capacitor plates are connected with the V volt battery, so potential difference across these two will be same. That is why the electric field between the plates will be same. So both are equal. When they're like it is not connected with this one, then we say like the electric field will be different. Here electric field will be more than this one, right? Because of dielectric, the electric field decreases E by K. That happens like when that is it is isolate, when the charge is constant. But here the potential difference remains same, so electric field will be same here. Clear? So electric field will be equal. Let's see some more questions. Okay, now let's see some integer questions. Question number 1. The plates of a parallel plate capacitor are charged up to 100 volt. At 2 mm thick plate is inserted between the plate. Then to maintain the same potential difference, the distance between the capacitor increases by 1.6. The distance between them increases. Find the dielectric constant. Okay. So first of all, like there's a capacitor, okay, where the dielectric medium is inserted. So it is charged up to 100 volt. Now dielectric medium is inserted. So potential, we know the potential decreases by K. So to maintain the same potential difference, the distance is increased. Okay, so we decrease the capacitance. So that means the capacitor is somewhat like this. So this one is dielectric, this one is without dielectric. Now the potential is 100. That means V1, V2. So V is equal to V1 plus V2 we can write. Okay, now the charge will be same because they are in series. So Q by C, C is 2 epsilon naught A by, the dielectric is K. So K epsilon naught A by 2 plus Q by epsilon naught A by 1.6. And this will be V, which is like the potential difference when V was there. So epsilon naught A by Q by 2, right? When there was no dielectric, so epsilon naught A by 2, and the distance between them is 2 only. So Q cancel here, epsilon naught is cancelled. So 2 is equal to 2 by K plus 1.6. So 0.4 equal to 2 by K. So K is equal to 2 by 0.4, which makes it 5. So answer is 5 here. Question number 2, find the amount of by which the total energy stored in the capacitor will increase in the circuit. So yeah, so we can find that energy stored first case. So you can see here how the charge will distribute. So this K is open here, so there is no charge flow here, and these two capacitors are short circuit. The charge will flow like this. So half CV square. These two will have a 0, 0, 0. This will have a half CV square. Final when it is closed, right? So now we can say here 1, 2, 3, 4. So this like again a short. Just 1 second. Now when it is closed, so the charge will flow here. So this time the charge will distribute here, okay, because there is a charge flow in this one also. So let's say if I say it is 0, 0, 0, it is V, V. Let's say it is X, it is V. So if I draw equivalent diagram here, so V, H and 0. So between V and H there are two capacitors are in parallel. H and 0 one capacitor, and between V and 0 there's one capacitor, and there's a battery here. So that means like these two are in series, so C plus C, 2C, 2C in series with this one, 2C by 3 and plus C, so which makes it 5C by 3. So potential energy final is 1 by 2 into 5C by 3 into V square. Now if you put the value here, so 1 by C is 3 value, it's 100 by 250, so 150 to yara, and this one is 3 cancelled, 100 by 250, 250 yara. So what is the increase here? 100. Okay, so that's it here. Question number 3. Steady is the charge on the capacitor. So steady state है, so there will be no charge flow in this one, so we can remove it. We just need to find potential difference between A and B. So what we can do here, so these two are in series, 6 plus 4 10, 2 plus 1 3, 3 and 10 are in parallel, so 30 by 13. Okay, so current is equal to we need to find the potential difference, right? So if it is 0 here, so it is 10. So current is basically 10 by 30 into 30, right? So it is 13 by 3 it is. Okay, now we can distribute the charge flow. The current will distribute, right? Because the resistors are connected, right? So let's say it is I1 here, I2 here. So now if we draw the equivalent diagram, so we have like 10 ohm, 6 plus 4, and here we have 2 plus 1 3 ohm. Okay, so current is 13 by 3, so let's say I1 here, I2 here. So I1 by I2 will be equal to V by R, right? So 3 by 10. So what is I1 then? 3 by 13 into 13 by 3, 1 ampere. I2 is 10 by 13 into 13 by 3, which is 10 by 3 ampere. So let's say it is 0 here, so it is 10. So 10 minus VB is equal to I1, which is 1 into 6. So VB equal to 4, and 10 minus VA is equal to 10 by 3 into 1, which is VA equal to 20 by 3. So now take a difference. So 20 by 3 minus 4, which is like 12 by 3, and this is the potential difference. So charge कितना हो जाएगा? 150 into 12 by 3. So it is just one second. Sorry, it's not 12 by 3. It is 8 by 3. My mistake. So Q is equal to 8 by 3 into 150. So 50 into 8, 400. Okay, so 400 microcoulomb answer आ जाएगा. Question number 4. It's like similar to that one. Now let's do the question number 5 first. I think it's very straightforward. There is an air filled 1 picofarad parallel when the cell separation is double, that with the so C is equal to 1, which is like now if it is wedge filled, so capacitance becomes 2. That means 2 is equal to K epsilon naught A by 2D. Now this is 1, so K is equal to 4. Yeah, so 4 answer, very easy. Question number 4. Let's say it is A, it is B, it is B, it is X, it is X, and this is Y. So, so 1 second. Let's do it somewhere. Okay, I'm doing it here, and just remove this part. Okay. So we just need to draw a replacement diagram here. So let's see how we can draw A, Y, B. This is Y, this is B, this is X. Let's see. Between X and A, there's one capacitor. Between A and B, there's one capacitor. B and Y, there's one capacitor. Y and X, there's one capacitor. And X and B, there's one capacitor. Okay, so from what we can do, A and B, there's a battery then. There's a battery, right? Between A and B, there's a battery. So just 1 second. So let's say there's a battery here. So you can see here this X and Y, these are in series. So Y and X, ये 2D वाला कैपेसिटर है, तो इसका कैपेसिटेंस epsilon naught A by 2D होगा. Remaining all will have epsilon naught A by D. So C by 2. Now C by 2 and this C are in series. So 3C by 2. Sorry, series C by 3. Okay, so this C by 3, which it has, right, so they are in series, right? So now then series, so then parallel with this C, so C by 3 and parallel with C, so 4C by 3. Okay, so parallel with this one, so 4C by 3. Now 4C by 3 is in series with this one, so plus C, which is 7C by 3, and last there is a parallel with this one, so 7C by 3 and C, so it is 7C by 10, and C is epsilon naught A by D. Okay, epsilon naught A by D. So that 1 second, this wait, this is like, what is it, 7 7C by 3, and this 7C by 3 is in parallel with this one, so 7C by 3 plus C, which is 10C by 3, C equivalent. Okay, now we need to find this. Okay, what is this C value? Is epsilon naught A by D. Okay, so okay, so that's value is, it's no, wait, there's a mistake here with it. 4C by 3 plus C by 3. Okay, I'll just do it again. C and C by 2, C by 3. C by 3 is in parallel with this, so 4C by 3. 4C by 3 is in series with this one, so 4C by 7. Okay, yeah, there I made a mistake. 4C by 7 plus C, so it is 11C by 10, and now C value is epsilon naught A by D, which is 7, so 7 cancel, so 11 answer. So answer of this one is 11. Okay, so with this one, the whole paper is solved. I hope like you learn something new. It help you to prepare this chapter. So thank you for watching. Thank you.